Hello everyone, welcome to my class. In today's class I'm going to cover solving a system of linear equations using determinants and Cramer's rule. Let me start the class right away. First, quick recall. Determinants of square matrix. A determinant is a number associated with a square matrix. For example, the determinant of 2 by 2 matrix A, whose entries are A, B, C, D, is a 2 rows and 2 columns, so that's a 2 by 2 matrix, is denoted by det A, that means determinant of A. This is also denoted by absolute value of A, that's the determinant of A. This equals to, the sign is the determinant sign, two absolute values there. Determinant of the matrix whose entries are A, B, C, D, and this equals to, we expand the determinant by multiplying the entries this diagonally, and we subtract the product of the entries along this diagonal. So then this equals to AD minus BC. Hence the determinant of given 2 by 2 matrix A equals to AD minus BC. Similarly, the determinant of 3 by 3 matrix A, whose entries are A, B, C, D, E, F, G, H, I, so 3 rows and 3 columns, is denoted by det A equals to determinant of A equals to determinant of this given matrix. We expand the 3 by 3 determinant along the first rows, so we start with a plus sign and then minus sign and then plus sign. So here in the next step we write the plus A and then we cross out the rows and columns including the entries A. So here we cross out the first rows and first column including the entries A. Then we have 2 by 2 determinant left, which is E, F, H, I. E, F, H, I. Next term is a negative B times the determinant. We cross out the second column and first row which contains the entries B. Then we have this determinant here, D, F, G, I. D, F, G, I. And plus the third term is plus C times the determinant. This determinant is obtained by crossing the third column and first row which includes the element C. Then we have the determinant of D, E, G, H. D, E, G, H. Now we do have this 2 by 2 determinant here. Then we expand this 2 by 2 determinant just like before and we multiply by A here and this determinant by negative B and the last determinant by positive C, and it turns out that the determinant of given 3 by 3 matrix is here, AEI plus BGF plus CDH minus AHF minus BDI minus CGE. Great. So now let's move on. We have alternate approach to expand the 3 by 3 determinant, which we call a Sarrus rule. In Sarrus rule, we augment the coefficient matrix with the first 2 columns, then add the products in blue diagonals, the diagonals are shown here, and subtract the products in red diagonals as follows. For example, this is the determinant of coefficient matrix, and we augment the 2 columns here, first 2 columns. This is the first columns and this is the second columns. Then we multiply the entries along the blue diagonals. So here A, E, I plus B, F, G plus C, D, H, which is here, and we subtract the product of entries along the red diagonals. So here the minus G, E, C, here is minus G, E, C minus HFA minus HFA minus IDB minus IDB. Great. And by the way, we do have the same these expressions here. Either we use alternate approach, that's the Sarrus rule, or we use this determinant expansions ideas, we will get the same final answers here. Great. So now let's move on. Quick recall. We can write the systems of linear equations as a matrix equations such as Ax equals to B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. For example, given systems of linear equations is here. The system is 3 by 3 systems, 3 equations with 3 unknowns. Here unknowns are X, Y, and Z. Let's find this coefficient matrix. The coefficient matrix is just the coefficient of X, Y, and Z in these 3 equations. So here 3, 1, 1, 1 minus 2, 3, 2 minus 3, 5, which is here. Similarly, the constant matrix is the matrix whose entries are the right hand side constant of the systems here. So constant matrix equals to minus 2, 1, 3. And the matrix equations of the form Ax equals to B here. This is the A coefficient matrix. This is the variable matrix. Here the entries are X, Y, and Z. And this is the constant matrix which you obtain here. Minus 2, 1, 3, minus 2, 1, 3. Great. So we can convert the given systems of equations into the matrix equations of the form Ax equals to B. Awesome. Now let's move on. Next, let's talk about Kramer's rule. First, the Kramer's rule for 2 by 2 systems. The Kramer's rule is an explicit method that uses a ratio of determinants to solve systems of linear equations that have the same number of equations as variables. For example, consider a 2 by 2 systems of linear equations. The given system is here. Ax plus by equals to m and cx plus dy equals n. Then this system of equations can be easily written in the form of matrix equations, which is Ax equals to B, where A is the coefficient matrix whose entries are A, B, C, D. X is the variable matrix whose entries are X, Y, and B is the constant matrix whose entries are M, N. Using the Kramer's rule, the solution of the systems is an order pair little x comma little y given as follows. Little x equals to the ratio of determinant dx over the determinant d equals to the determinant in the denominator is simply the determinant of the coefficient matrix whose entries are A, B, C, D. So A, B, C, D. And in the numerator, the dx is the determinant obtained by replacing x columns of the determinant d by the constant column. So that is, we are replacing the coefficient of x, which is A, and coefficient of x, which is C, by m and n respectively. So here we replace A and C by m and n. Similarly, little y equals to the ratio of determinant dy over determinant d, which equals to the determinant in denominator is simply the determinant of the coefficient matrix, and in the numerator the determinant dy is the determinant obtained by replacing y columns of d by the constant columns. That is, we are replacing the coefficient of y in the first equation and in the second equations, that is b and d, by the constant m and n respectively. So here we just replace this column bd by mn in our numerator. Great. So now this x and y are the solutions of these given systems. Similarly, the Kramer's rule for 3 by 3 system is as follows. Consider a 3 by 3 systems of linear equations. So here I put the suffix for the constant here. So a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. So we have 3 equations and 3 unknowns. Unknowns are x, y, and z, and the coefficients are here: a1, b1, c1, a2, b2, c2, a3, b3, c3, and the constant on our right hand side on the systems are d1, d2, d3. Then next, we can easily convert these 3 by 3 systems into a matrix equations of the form Ax equals to b, where A is the coefficient matrix, X is the variable matrix whose entries are little x, little y, little z, and B is the constant matrix whose entries are d1, d2, d3. Then, using the Kramer's rule, the solutions of the system is an order triple little x, little y, little z, and is given by little x equals to the ratio of determinant dx over determinant d, little y equals to the ratio of determinant dy over determinant d, and little z equals to the ratio of determinant dz over determinant d, where d is the determinant of the coefficient matrix. So here the coefficients are a1, b1, c1, a2, b2, c2, a3, b3, c3, so which are here. So d equals to the determinant of the coefficient matrix. Dx is the determinant of the coefficient matrix which you obtain by replacing the x columns by the constant columns. Similarly, dy is the determinant of the coefficient matrix which you obtain by replacing the y columns by the constant columns. Similarly, dz is the determinant of the coefficient matrix obtained by replacing the z columns by the constant columns. Great. Quick remark: when two rows are interchanged, then determinant changes sign. If two rows or two columns are identical, then the determinant equals 0. Determinant of an inverse matrix is the reciprocal of the determinant of the matrix. Awesome. Now, with those ideas, now let's solve some example. So example first, solve the 2 by 2 system of equations using Kramer's rule. So given system is x minus y equals 5 to x minus y equals 2. So we have 2 equations and 2 unknowns. Now let's begin the solutions. So first let's find d, dx and dy. These are the formulas in Kramer's rule. So the d is the determinant of the coefficient matrix. Dx is the determinant of the matrix obtained by replacing the x columns in the coefficient matrix by the constant. Similarly, dy is the determinant of the matrix obtained by replacing the y columns in the coefficient matrix by the constant. So here, so then d equals to the determinant of coefficient matrix. So here the coefficients are 1, minus 1, 2, minus 1. 1, minus 1, 2, minus 1. Similarly, dx is the determinant of the matrix obtained by replacing the x columns in the coefficient matrix by the constant. Our constant are 5, 2. So we replace the x columns in the coefficient matrix by the constant. So here it's 5, 2, and then the second column of the coefficient matrix as it is minus 1, minus 1, minus 1, minus 1. Similarly, dy is the determinant of the matrix obtained from the coefficient matrix by replacing the y columns by the constant. So here 1, 2, the x column as it is from the coefficient matrix, and we replacing the y columns in the coefficient matrix by the constant 5, 2, 5, 2. I hope this makes sense to you all. So next, let's expand those determinants here. So the d equals to, so to expand this 2 by 2 determinant, we multiply this diagonally, and we subtract the product along this diagonal entries from the product along this diagonal entries. So here 1 times minus 1, 1 times minus 1, then minus from formula 2 times minus 1, 2 times minus 1, and we simplify, we got d equals to 1. Similarly, dx equals to, we multiply along this diagonal 5 times minus 1, which is here, and then minus from formula 2 times minus 1, 2 times minus 1. We simplify, dx turns out to be negative 3. Similarly, dy equals to, we multiply this diagonal entries 1 times 2, which is here, and minus from formula, and we multiply the entries along this diagonal, which is 2 times 5, 2 times 5, and we simplify, then dy turns out to be negative 8. So now, then by Kramer's rule, the solutions x equals to the ratio of the determinant dx over d. Dx is negative 3 over d is 1. So negative 3 over 1 is negative 3. Hence, the solution x equals to negative 3. Similarly, solutions y equals to the ratio of dy over d. We found dy equals to negative 8. D equals to 1. So negative 8 over 1 equals to negative 8, hence y equals to negative 8. Consequently, the solution of the system is an order pair, little x comma y equals to negative 3 comma negative 8. Great. I hope this computation makes sense to you all. Now let's move on. Let's do example 2. Solve the 3 by 3 system of equations using Kramer's rule. So given 3 by 3 system is here. So 3 equations, 3 unknown. So the equations are 3x plus y plus z equals negative 2, x minus 2y plus 3z equals 1, and 2x minus 3y plus 5z equals 3. So now let's begin the solutions. First, let's compute the determinant d, that is the determinant of the coefficient matrix, and then the determinant dx. Dx is the determinant of the matrix obtained from the coefficient matrix by replacing x columns by the constant column. These are the constant column, by the way. Similarly, dy is the determinant of the matrix obtained from the coefficient matrix by replacing the y columns by the constant columns. Similarly, dz is the determinant of the matrix obtained from the coefficient matrix, replacing the z columns by the constant columns. So here, to distinguish, I put the pink color for the constant here. So the constant columns has entries negative 2, 1, 3. We replace the x columns by the constant columns in dx. In dy, we replace the y columns by the constant columns. Similarly, in dz, we replace the z column by the constant column. I hope this formula makes sense to you all. So next, let's expand those 3 by 3 determinants here. So first, let's compute the determinant d. So here, we are expanding this determinant along the first row. So here, so start from this 3, times the determinant. So this determinant is obtained by crossing the first rows and first column containing the entries 3. Then we have -2, 3, -3, 5, which is here. -2, 3, -3, 5. We expand along the first rows, starting from the plus sign, then minus sign, then plus sign. That's the formula. So we have -1 then, minus this one. Then we cross out the second column and first rows containing 1. Then we have the 2 by 2 determinant left, which is 1, 3, 2, 5. 1, 3, 2, 5. Similarly, the third term is plus 1 times the determinant. This determinant is of size 2 by 2, which is obtained by crossing the third columns and first rows containing this 1. We have left 1, -2, 2, -3. 1, -2, 2, -3. Next, let's expand this 2 by 2 determinant, this 2 by 2 determinant, this 2 by 2 determinant, and multiply by 3 to this first determinant expansions, and multiply by -1 to this next expansion of the determinant, and similarly multiply by 1 to this expansion of this determinant in the next step, which I did here. So 3 as it is, then we multiply this diagonally. -2 times 5 is -10, and then minus from formula, and we multiply this diagonal entries. -3 times 3 is -9. So the -9 times the minus from formula gives us +9, which is here. Similarly, -1 as it is, 1 times 5 is 5, -2 times 3 is -6, so 5 minus 6 here. Similarly, +1 as it is, multiply this diagonal entries here. 1 times -3 is -3, and then minus from formula, then multiply 2 times -2, which is -4. So -4, and there is 1 minus from formula, makes it +4, which is here. So I hope this computation makes sense to you all. Then let me scroll down here. Then after simplifying, it turns out that the determinant d equals to -1. Now similarly, we can expand these other 3 by 3 determinants, dx, dy, and dz, exactly like we expanded the determinant d. So here, then with the same idea, the dx turns out to be 9, dy turns out to be -13, and dz turns out to be -12. I hope you understand this computation, so please pause the videos and try to expand these determinants and get the answers here. Great. So now, by the Kramer's rule, then the solutions, little x equals to the ratio of dx over d, little y equals to the ratio of dy over d, and little z equals to the ratio of dz over d. So we found here, so maybe that's better, that's the dx value. Hence, x equals to, then dx over d equals to 9 over -1, d, the value of d is -1, by the way. So here, so then this turns out to be -9. Similarly, y equals to the ratio of dy over d. We found dy equals to -13 over d equals to -1. Simplify, it gives us y equals to 13. And similarly, z equals to the ratio of dz over d. We found dz -12, d -1. Simplify, it turns out that z equals to 12. Hence, the solution of the given system is an ordered triple, little x, little y, little z equals to the order triple, -9, 13, 12. So we solve these 3 by 3 systems using Kramer's rule. So we finish these sections as well as we finish chapter 8. Thank you.